guys, to another little testament to our little first-person shooter here. Now, in today's episode, I will be showing you how I got this nice little gun movement behavior, or maybe see the upgrades, I guess. So, we got our upgrades here. A little crouch going on now, and we still got our nice little run, and we're going to walk. Still haven't done the animation from there. I guess that will kind of be one of its things. Now, because due to the way that this works out and everything, this nice little script right here has nice little foldouts now. Before it was really long, it wasn't too intuitive, so I cleaned it up quite a bit and gave it a little bit more polish. Okay, and you've seen how that works, and let's see how this works. Now, auto M handler is something I cooked up just for automatics. It can work for various other weapons, but it's abstract enough where we could always rewrite this anyway. Now, I don't exactly have to have this current handler here, but if I type in the setting and I want to find a position and movement stuff, all I have to do at runtime, which I'll show you, is go in here, go bloop, pull up the weapon. Okay, now since the weapon is here and everything, we've got our nice little inspector. Now, to find settings for current positions and stuff like that, it's kind of not very nice, you see. So I developed this setting rule right here. It will not be able to set the position at all. So we have free reign to move this over here, here, up, down, and let's reset that to there. And I believe current rate still sets, but the positional data doesn't. So we could, put our gun right here and be really ridiculous, or like right here and take up the whole screen. We have free reign to do this, so it's very easy to get the aim positions, okay? And once you find them, all you got to do is go down to your prefabs, see your settings right here, go down to prefab, and put these values in here, okay? Like, 111, for instance, okay? And even though we come out of play mode and stuff, these will persist, okay? Because we're changing it from the prefab level instead of the instantiated version. Now, it has to do with things about cloning, how Unity works. It takes the original, it clones, and then it destroys the clone later on. But anyway, it's just the way that it is. Now, we've still got all our little settings. We got a current handler, which we don't set these at all. It's mostly just for, finding the positional data. We got our hip position, field of view and all that stuff. Aim handler and our kick handler. I moved it over to m.handler because it made more sense for it to be there instead of being in our weapon script. That's just my handle about it, because it doesn't seem like something that should be there, because it's movement code for a weapon, which movement code, the job of it is to be in the handler for it, which is this script. So in any case or scenario, we're going to go over here to our nice little coder. Okay, and this is not what this is for. And we're going to go here. Now, this is a seal class for mHandler, which is just a component that has nothing. It's an abstract class just to signal me that this is what this is for. Weapon movement moving handler. Okay? Now you'll see this current handler values, hip handler values, aim handler values, and kick handler values. These are all classes. Okay? Which, if we look at it, sneaky peeky, which is current handler, hip, and this stuff. I put these all in separate classes for one specific reason. If I wanted to make a function that only runs on the hip handler, then I can. I can make these all one thing, but remember, current handler has the setting thing, which is very, very good for us because of, hey, we need the position stuff. We need an easy way of setting positional stuff, or at least finding the values in a more intuitive way. That way our workflow goes better, okay? And I can always, get functions, write functions into this class to make it a lot easier. But this is basically what it's for. Field of view, move rates, hip position, I've got specific names. Makes it very, very easy for us to know what's going on, right? I mean, that's the whole point. Okay, so we know why this is here in our kick handler. Equipment manager is nothing you guys need to worry about. You know what weapon position stuff is for. It's just the weapon position, our main game object, the first one. It's for aiming and stuff, okay? In our start, we get the eye controller inputs. Our initial, it's for setting references, kick.initial. And movement is a update loop for lerping the field of view, which we're going to change this from mathf.lerp to a different one. I just ain't done it yet. We're going to go, it's going to be called mathf.moveToward. See, mathf.lerp is really good, but you can get floating point numbers, which are really, really big, and, it just doesn't interpolate all that great. So, it's kind of left hand talks to right hand. The in between, which is your body, is what interpolates it. And sometimes left hand is missing a finger, where right hand goes, hey, are you okay? And you get, oh, yeah, I'm fine. Not. Secretly, I'm missing a finger. Yeah, that's how that works. And you don't get everything. Okay, you'll have like 0.00000001, and it'll never move, which is kind of dumb. But anyway, we got our zoom features, which current handler, current field of view equals aim handler dot aim field of view. See how those naming conventions come in hand? Aim handler, current handler goes to hip, because this is our true statement, okay, and this is our false statement. Now, our float dist is a distance check between the weapon and the current position. If it's greater than 0.001 F, notice that floating point stuff? Yeah, that's what that's all about. Our weapon position local goes vector 3 lerp our position to our current position and then current rate at a fixed time delta. Okay, I found it to work better than time.delta time because this goes on the physics engine, which will run regardless. Okay, the physics tick will always run at a flat rate Doesn't care about per update or anything like that. It will run. It runs actually on its own thread, I believe, through Unity. So we've got this right here. So the distance will be less than 0.001. Okay, so why do I have this else statement here? This else statement is for those floating point errors. Now, because time is linear and it always goes up, we can go time.frame count. Ask the game engine how many frames has went by. Then we're dividing it pretty much by 20. So every 20 frames, when it loops back and goes to 0 because of the division, it will run this line of code, which forces, when it hits this distance right here with that floating point junk at the very, very end, it will force the local position to be like that. It'd be like forcing vector3.0 and vector3.up. It goes up one position. No interpolation, no nothing. So it destroys this floating point number stuff, so it's not lerping the whole time every time. Okay? That's the whole point of it, because if it keeps lerping and lerping and lerping, it's running this lerp code, which, you know, it's not very heavy, but if we can get it to stop lerping, then that's extra code that's not running off the engine. It's just doing a static, more or less, position. And it only runs this code every 20 frames, because when it goes back to 0, boom, it forces it. Now this code will never run unless it's below this distance, which is very, very small. So you'll never even notice that we're doing this code, which, you know, helps us a little bit. Okay? Our aim position, our aim control, we don't really need this here, but, you know, I keep it there because this is coming from the weapon script, which we already went through. It's FPS weapon or something like that, I believe, in the title. It's very easy to find. We set the current, our current, which is a function, and we pass it a hit position. Current handler, current rate equals. So we're just basically moving the stuff. So current takes a vector 3. So current, if current handler dot setting equals false, which means it's perfect normal state, you know, then it will set the current position. Okay, which that's all it does. It's a small little function, so we don't have to keep writing current handler position, current handler position, current handler, blah, 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 all the time. We just call this function, and it does the work for us. So we return false to the weapon script, or we return true. And that's pretty much it. This actually should probably be a void, believe it or not. But for some reason I have a bool, I don't know why. And then we have our fire move. This is purely solely for kickback. And that's why I call it fire move. Because when we fire, we move. And we do it procedurally with this. And kick handler, kick transform, translate, and it's pretty simple. I mean, it really is. I mean, I don't think I have to explain that. I think this right here pretty much explains it. The run, we're doing the same thing. Well, when we go to the running thing, it will not execute this code in our controller because we're running, we cut out. So all this other code will never run because it doesn't get an update loop. This script will potentially just be dead. Not like destroyed, but it'll have no more functionality at all. No update loops. Because in order to get to the move update that runs, we have to have running equals false. Okay, so we're not running. So we need this kind of stuff to work. So we take the current rates to hip, 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 and then we just lerp it in this function. So this will do it every time our controls say, hey, we're running. So every single frame, it'll make sure all this stuff goes, which setting that current every single time seems kind of ridiculous. I may have something better for that later. And we've already pretty much went through this. Current handler, values, and you guys can all like pretty much pause the video and write this stuff down or type it, okay? So I really shouldn't have to explain too much of this, okay? Now notice this kick right here. We've got an initial, okay? This happens in the start of our thing, not the start here. This initial function, when we initialize this script, we set the kick initial. And what this does is we have a script called smooth return, okay? And what this script does is it smoothly returns to where we need to go. Target, rotation, and we do velocity. All it is taking the local transform and putting it at a target position. We're using smooth damp for it, which smooth damp is one of those strange functions that it's really nice because it will never overshoot. But there is a gotcha. It will not do negative numbers for crap, okay? It will literally be terrible for negative numbers, which we don't really use negative numbers at all. So I don't use negative numbers in my thing for kickback and stuff, which ends up being it works. I'm looking for a better solution than this, but I haven't found one yet, and I don't want vector3.lerp. And remember, this is a regular monoscript here. Okay, so this attaches the game object. And if you look at our code right here, m.mover equals kick transform dot get component, and we want to get this. If it's null, then we add the component. So if we forget, our script will go, hey, you forgot this. Please stop and fix your mess. Which we should have an error message, right? Debuggy log error, because it should be an error, and we're going to type a message in here. Kick trans needs a smooth return script and there we go. It will give us an error message when we don't have one. So it's kind of like making sure we don't mess up. Okay? And here would be another one, okay? Is we're going to take this initial, all right? And we're going to go if kick trans does not equal null, then we do this, okay? Which is inside this if statement right here, okay? But we're also going to do this. And this will save me a little bit of headache, because if you go to shoot and it pulls the exception because this transform is not actually in here, Because this isn't a mono behavior, so it doesn't get start or update or anything like that. It gets no callbacks unless we call it from another script, which, you know, some people may not like it, some people do. I guess it all depends on your style, really. Okay? But if this is not null, it will run this code. So it will never even try to evaluate this. But if it's null, and Unity tries to pull an exception because it's null, it'll slow down Unity like real bad, and you'll be like, what the crap's going on, right? It'll start being all dumb because it's trying to do something. And exceptions, when it comes to exceptions and some errors, they are extremely expensive. So that's why you get to slow down, and your Unity just acts like it just quits responding sometimes. Or maybe not. I mean, it all depends. But sanity checks are not a bad thing. So we're going to go up here. We're going to do this. Okay? We're going to go. Is missing, and Unity is freaking out. Fix it, please. ... There you go. So that will give you guys a nice little error message that pops up and goes, hey, wait a minute. What? Right? And that's great, because that's also the reason why I have Pacific scripts designed. And these classes are not necessary. You can just leave these variables like current and all that inside the script. But if you want that nice little fold down way and, you know, keep things tiny in the inspector, then you're going to have to do the class way. Okay? And that is all for our little game here. And this takes care of all that zooming and moving around stuff. It's much more refined than our older system, a little bit. So if you like this video and you are more interested in other stuff like this, please hit that subscribe button, smash it, break it, call YouTube's technical support system and go, hey, I want to subscribe to this stuff. And I thank you for watching. This is War, over and out.